So just look at another example, another problem, which is the toy problem. And in this problem we have a dust cleaner agent, and the main objective of this cleaner is to clean the all boxes. So initially we have two boxes, and this is the dust which is present in this box, and this the dust the present in this box. So here is the dust cleaner. So हम इसको देख लेते हैं, what are the available action for this. So just इस फिगर को भी आप देख रहे हैं, तो ज़रा गेस करें कि कौन कौन से एक्शंस जो हैं वो ये परफॉर्म कर सकता है. So this cleaner agent can move towards the right direction from this box to this box. अगर ये इस box की तरफ जाता है, then this new state will occur. So if this agent move towards the left direction, so there is no box in left direction, so it will remains here. So ये same state ही रहेगी. And but if he suck this dust, so so the new state will generate. So this is the new state. So in each states you can on each state you can see that there are three actions, and the one of तो एक एक के ऊपर क्या करता है कि वो उसी तरह से रहता है, लेकिन दो के लिए हमें नई स्टेट्स जो है वो मिलती हैं. So look at this state, and if the agent move towards the right direction, so ये कोई नई there will be no new state. So नई states नहीं generate होती, तो ये वही रहती है. But if the agent move towards the left direction in left box, so then this state will generate. So अगर जो है वो इसको suck कर लेता है, इसको dust को, so then it will generate a new state. So तो यहाँ पे देखें, यहाँ पे कोई भी dust नहीं है इस box के अंदर. So in the same way you can see that here the right action when we apply on this state, and then the left action, and in the same way the action S, which represent the uh, cleaning या suck state. So suck action. So अगर हमारे पास जो है वो clean करता है, तो हमारे पास ये state बन जाती है. So there are 8 different states. So हम देख लेते हैं कि what is the problem formulation for this problem. So look at this slide. So there is another new thing. You can see that the total number of possible word state is 2 multiplied by 2 raised to power 2, which is equal to 8. So this is the formula, that n multiplied by 2 raised to power n, and where n is the locations. So a large environment with n locations has 2 multiplied by 2 raised to power n states. So हमने पिछली एग्जांपल के अंदर हमने डिफरेंट सीक्वेंसेस देखे थे इसके अंदर कि इतने पॉसिबल नंबर ऑफ सीक्वेंसेस होंगे. तो यहाँ पे हमने एक और चीज़ देखी कि हमारे पास जो है वो इस प्रॉब्लम के लिए कितने पॉसिबल नंबर ऑफ स्टेट्स होंगे. So what is the initial state? In any state can be designed as an initial state, designated for as an initial state. So what are the actions for this problem? The action is right, left, and the suck. So there are three different actions. So what is the transition model? So if we provide the initial state or any state, and also we provide the any action, then the resultant state will be the our transition model or resultant value of the transition model. तो यहाँ पे भी अगर आप इसको रीड करेंगे तो यहाँ पे भी कोई ना कोई उसने एग्जाम्पल भी लिखी होगी. So at the goal test, so this checks whether all the squares are clean. So हम चेक करेंगे कि वो squares जितने भी हैं वो सारे clean है कि नहीं. And the path cost, each step cost is 1. So the path cost is the number of steps in the path. So this will be our path cost. So in our next slide, so solution, what is the solution quality? How can we measure the quality of a solution? So the solution quality is measured by the path cost function, and an optimal solution, optimal क्या है, जो कि हमें क्या करे, optimal solution has the lowest cost among all solutions if there are multiple possible paths the goal reach at goal from initial state. So if there are multiple paths, so if our solution give us the path which have the lowest cost, so that will be the optimal solution. So in our formula, n represents the locations and the value of n for this problem is 2. Just जरा सोचें कि how the value of n is 2 for this problem. So why the value of n is 2 for this problem? So initially, basically, there are two boxes. So these two boxes are two different locations. So that's why the value of n is 2. But as a whole, these two boxes, when we combine these two boxes, these two boxes represents a state, but there are two locations. So n is equal to 2. So look at another slide, which is very interesting slide. So so using this concept, we will move towards the another very important concept. We can basically this slide represents as representing that we can convert any problem into in the form of a tree. So this is a state. So as we discussed in our 8 puzzle problem, so there are many different states. So this state can be represented as a node. So if this is a node, these are the actions, and when we apply the action, then it will generate a child node. And there is also a concept of tree. So जो हमने example की है, हम उसी को ही थोड़ा सा इसके साथ मैप कर लेते हैं. So we talked about this definition, this problem in previous lecture. So this is our node. So we can represent this state. So sorry, this is our initial state, and we can represent, if we represent this state as a node, so then these are the action can be represented as an edge, then the newly generated state will be our child states. So there are total 4 actions. Then the actions or branches for this node are 4. So the initial state will represent, we can represent this initial state as a root node, and then this node will be our child node. So in the same way, this is another child. So if we apply these actions on this node, this will also generate a new states. So this will become a parent node, and the newly generated form, when we apply the number of these actions on this state, so the newly generated nodes will be our child node for this. So in this way, we can represent our problem in the form of a tree. So a node will represent the state, and the edges will represent the actions. So we will apply every action on this state, and we will generate a new node or new state. So look